Oh, don't get don't get in trouble not closing your stuff. Okay. Save. Got green bars. Go back to Unity. Update. All right, and there we go. All steady weddy. Sorry, let me bring it back. Boop. You can mark it as complete, and we will move on. Move the player left to right. We have to actually use the horizontal input to translate the player left to right, left and right. Okay, let's take a look. 2.1 player positioning. Move the player left to right.
All right, so we've added a way to get input whenever a player presses a key. Now we actually need to use that input to be able to translate the player left and right. So what we're going to do is in our update method, we're going to get the transform of our object and we're going to translate it. And in this case, what we're going to do is we're going to get the direction that we want to go. So we want the player to go left or right. So we'll get vector3 dot right, and then we'll multiply this by our horizontal input so that way it knows to go positive or negative. And then we're going to just make sure that it updates over time and not every single frame. And then we're going to set it to a speed. So instead of just using a number, let's just use a variable because we might reuse this again anyways. And we'll close this statement. Now the speed variable is yelling at us because it doesn't actually exist yet, so we're going to create that. So we'll make this a public variable as well so we can see and change it as we need. This will also be a float so we can be really precise. And we'll call this speed, and for now we'll set this to be about, maybe let's call it 10. So now if we save, and then we go back into Unity, now when we press play in our game view, we'll just make it a little bit larger. As we go left and right, you can see that the player moves back and forth, which is perfect. That's exactly what we want. Now, we have another problem here where the player actually goes off the screen, which is pretty bad. Actually, in fact, you could probably just have the player fall off of this map, which is definitely not something that we want to happen. So we're actually going to fix that in a later part. So to recap, we added a new variable to our player controller script called speed. We made it a public float so that we can change it whenever we need to later. And then we added another transform.translate method to be able to move the player left or right over that speed over a certain time. So now it's your turn.
And I've been muted all this time. Okay. Okay. So I typed all that up. I I cannot seem. Why can't I? Oh, I have to do the thing, don't I? Have to click on him and click on the farmer. Click on the okay player. There we go. That's what I do. That's all right. So you can move left to right. So that works. All right. Let's move. Oh, sorry. That's why it's purple. And let's move on to the next one. Sorry, I was muted. Just typing in the code. The code is incorrectly, as you can see. Yee. And boop. Okay. Load the T pose. All right. Let's go back. Boop. Step is complete. Come on, let's hurry up. Yeah, I'm going to stop at 2.2. So we're going to finish up 2.1. And if it's a little bit early, I'm going to end it a little bit early. So let's keep going. Keep the player in bounds. We have to prevent the player from going off the side of the screen with an if-then statement. Oh, so we're into new territory. So let's see how to keep the player in bounds.
Great. So we've added a way to be able to control the player and move them left or right. But we have another problem now where the player can actually go off of the screen that we can see. And in fact, if you see the scene view, our player can actually just go all the way off the screen. And then eventually they might actually just fall off the map, which is no good. So what we're going to do is we're going to set a boundary so that the player cannot leave this area and they'll stay within what we can see in the game. In order to do that, we're actually going to start using some logic in programming so that we can control when we want something to happen and when we don't. If we go over to our IDE, now in our IDE, what we're actually going to do is we're going to add something called an if statement to our update method. So if we go to our method and we create a new line by pressing enter, now we can type in if, and then we'll put next to it some parentheses, and then if we press enter and add a curly bracket, which is just under your minus key on your keyboard, and we'll press shift to make that curly bracket. Why? Because if we just press the button where the curly bracket is, we'll make square brackets, and that's not something that we can use, nor do we want right now. So this is an if statement. What will happen is when this line of code happens in our update function, if the thing inside of these parentheses is true, if it's something that is happening, then it'll do whatever is inside of this code block. So what we're going to do is we know that the player is moving left or right on their X position. Now we want to bound that within a certain range so that way they don't go off the screen. So what we'll actually do is in our if statement, where we're checking what's going to happen, we're going to write transform, and then we're going to get the player's position, but we're going to get the X value specifically. And we want to make sure that it's less than -10. Now there's a problem here because, as we know from before, less than is not something that you can tell a computer. If you remember, there's a lot of different symbols that you can use, like the plus sign or the minus sign. What we're going to do is we're going to use a left caret symbol. And so this means less than. So if the current object's position on the x is less than -10, now we can do something. So now that we know that whenever the player's position gets to less than -10, what we're going to do is we're going to get their position, and we're going to set it to a position that we want them to go to. So we're going to use a new vector 3. That way we can create a position that they go to. Because we don't want the player to go less than -10, we want to keep them at -10 whenever they try. So we'll put -10 for the x value, but their y and their z positions never change. So if we type transform dot position dot y, that'll get their y position, and then transform dot position dot z. And then if we close off that statement, now if we save and then we go into Unity, and now when we press play, if we try to go to the left in the negative direction, when we hit 10, you can see that the player runs into this invisible wall and they can't move any further. So going into our IDE, what you're going to do is you're going to write your own if statement in the update function to get the player's position, and if it ever goes less than -10, so say -11, just set their position to be a new vector 3 for their position to be at -10, but we don't want to change their y or their z. Now it's your turn.
Okay, got it. Okay, I got it. This is like the if then statements, the or statements and stuff like that that I learned in programming.